per the requirements. From top edge say 40 millimeters, from this edge 80 millimeters. So here the hole will be placed exactly. So by using this projection sketch, I can place the hole properly. Here I can use, instead of blind, say through next. So through hole it will be. See here, it's a through hole. It has drawn the through hole. It will be simple hole. This whatever the hole we have drawn, it's a simple one. There are so many options also available in it. If I create a hole over here, type is simple. I can have tapered hole. The angle you can give it as per the requirement. See, this is the inside angle 30 degrees. Let me reduce it once more. So this is one hole with taper of 20 degrees. There is one more type of hole called as counter bored hole. See here. The diameter value I will increase it little bit. 30 millimeters. 10 mm. Sure. So this is what we get. This is what? Counter bored hole. Counter sunk hole. Counter sub headed screws can be fitted. Little bit increase the angle. See here. Counter sunk. A combination of both of this counter sunk plus counter bore, counter drill hole. See here, this is a typical here counter drill hole. I use the dynamic sectioning. Place it here and see. I'm taking the section, dynamic section. Got it. We can create a hole, a simple hole with threads, threaded hole. There are some metric thin, metric thick pitches as per the standards. See here. Only thing is that the threads will not be visible. These are called as the virtual threads. But when we take drafting of this particular part, there it will show that there is a thread. If I generate some NC program for CAM, there also it will create the threads. It will analyze here the threads are there. See, there is one analysis toolbar at bottom, and here there is one option called tab or thread analysis. It shows how many threads or tabs are there. So here it is showing there it's some thread over there in this part. So here only one hole with thread. If I take it this one, and for this also I will take it thread depth of 50, enter, do this thread or tab analysis and say apply. See here it is showing two tabs. If it is outside, then it is called threads. Outside to the cylindrical parts, threads. Inside will be internal threads will be called as tabs. So here as well as here, at both these locations, it is showing threads or tabs are present. Okay. Now there is one option over here called that solid combine. What is solid combine? Let us see it. Make a new part, and there I create two sketches. Two sketches I am going to create. that is in YZ plane, another in ZX plane. I create one another profile, another sketch this way. Then I will use option called as solid combine. So select the first component, second component. See here, this is what we'll get. And if I see from this side, I will look as if it is projected this way, normal to the sketch. Now here, normal to this another sketch. Suppose little bit I modify this. Okay, exit. So we have modified it. Solid combine this to this. See here. Otherwise, you would require some more number of features to do it, but in one step only we have created this particular feature called solid combine. For some critical components, generally we use this particular feature. To draw some of the specific parts, like fork of a knuckle joint, there we use it. See here, or in fact I delete this. Do not delete aggregate elements. We have two sketches. We have two sketches over here. One is this one, which is in XY plane. Another one in YZ plane. This way with exact proper dimensions. Now use solid combine. Combine this one and this preview. Okay. See here. In only one step, in one solid combine, we have created this part. Otherwise, it would be very difficult to do it. We may need to create some tabs and pocket, then add some fillets as well. But only in one step, we added this with the help of solid combine. Only thing is that proper sketches we have to draw based on the geometry. Okay. So this is solid combine, which adds the material. So what you people do is just see these tools which just I have explained to you. Have a practice. I will show you how to model this part. Okay, so let's start. I create a new part, give some name to it. Are students able to do it? Mentors? Any doubt regarding this particular part? Yes, dear students, please reply. Shall I explain this part, how to model it? Hello, please reply. Mentors, please reply. Mentors, are you there? Mentors, are you there? All mentors, please reply immediately. Otherwise, it's very difficult to understand whether students are getting it or not. So, mentors, you please be attentive. Take the doubts from the students. Other college mentors, are you there? Are students doing it? Practicing? Other college mentors? So, shall I explain this, how to model it? Mentors? Mentors, you type your names before your college so that I can communicate to you. So let us start to model this particular part. As initially also we have discussed, to start a particular model, it is very important to select the base feature. What should be the first feature? The selection of proper first feature always helps a lot. So for that, I will take, this is the sketch in say YZ plane. This is what I will draw and have extrude. Okay. Another important thing is always we should try to maintain the symmetry about the principal planes x, y, y, z and z x planes. So select this YZ plane and let us draw so the sketch. like this. We'll constrain it, we'll create symmetry. See, for this particular edges, make symmetry, give the dimensions. This dimension is, I think, 74, but before that we'll give dimension of 42 over here. 42. We need to give symmetry between these two edges as well. Control, select this edges and at last the axis, and constant definition dialog box, symmetry. So this is what we got. Double click this, make it 74. This way, this vertical height. Here vertical height is not given, so this one will take it as 20. 20. Okay. This also we need to give it 20. Then from here to here it is 44. This point and here 40. Then this is complete 44 from here to here. 22 plus 44, 66. 66 is the value. See, in isometric view, here it is what we have drawn it. Exit workbench, make a pad. Both sides will extrude it. 60 is total, so 30. 30 on one side, 30 on the other side. 30. Okay. So this is the first picture we have drawn. Here we can also add the circle, so that in the same feature we can get the pocket to be performed. Diameter value of 26. 26 is the value. This is 22. See here. Then exit to get this. Okay. So very good, very simple it is. Now we will create this. That is the circular one, R30. For that I have to use the ZX plane for it. The center for it, take radius of 30. The center should coincide with here. Coincidence. Still it is not green because it is not constant with vertical. Coincidence. Now say exit. Now make a pad, mirror extent. What extent? 26, half of 26. So 13 on one side, 13 on the other side. So this is what we'll get it. Now sketch it in this plane. Draw one circle. Make it concentric with this edge. Radius of diameter 44. So diameter over here and 44. Okay. So in this way, diameter 44 we have taken it, and then we'll also draw a, because here you will see this is vertical, so we'll draw the feature like this. Let us give dimensions. This to this we have to give it, but before that we'll make symmetry first. Symmetry of this, symmetry of this as well. This is 10 mm, this is 30. So this is 10, and we'll give dimension to this line as 30. So it can move vertically, so we'll control and say coincidence with the H, remove this portion. See here we have drawn this particular sketch, and then I'm going to use the pocket feature to remove the material. Say okay, so this is what we got, and one pocket got added over here. Now what is the remaining thing over here? It is 26, this, yes. So this is what we did. In 3 steps only we have modeled it. What I will suggest you is you can try to create one sketch this way, and another sketch it this way, and use solid combine feature. Use solid combine for it. So that is also possible. So that will also have, so this is, you can take this your class work to use solid combine to create this particular model, to this model. Okay. Now there is one more feature in this sketch based feature tools. It is called as multi-section solid. So I created in the YZ plane one sketch, another plane I want to create another sketch offset to this, parallel at some distance. So for that I will use the option called as plane and offset from plane, offset to this plane. What distance? I want to have it at 200 millimeters. Say okay. A little bit some more, take it 400 millimeters, and in this plane, say here plane is drawn at 400 millimeters offset to YZ plane. So there in that plane I am creating another rectangle this way. So we have two sketches, sketch 1 and sketch 2, one and in YZ plane, another one in the plane 1, this rectangle. Here one option that is called as multi-section solid. Select the sketch 1, this one, and another sketch, preview. So in between these two rectangles it will create a solid. It will create a solid this way. I hit undo. One more plane parallel to this plane 1 at say 500 millimeters at some distance. Another sketch. a third sketch. Similar rectangle only, little bit different size. So here we have three different sketches. Once again I will select multi-section solids, select first sketch, second sketch and third sketch. Preview, say okay. So this is what we'll get. So in between these three sketches, three profiles, it has created the multi-section solid. If we are creating it, there is something called as a closing points here. For the sketch there is closing point over here. I select this one second. It is having here. Depending on how we draw it, it can be at this location as well. The closing point should be matching to each other. So first is over here, so second also should be here. For third sketch it should be here. If it is not matching, let us right click and say replace. We will get a twisting effect. Say preview. Before that I will have one more sketch to be added, third sketch, preview. So this is what we will get. So this closing point, I join it over here, this here. I can replace this as well, replace to this vertex. So preview, and this way we got a multi-section solid. I repeat it once again. I say undo, multi-section solid from here to here. So closing point 1 to closing point 2. Suppose I say right click and replace this over here. Then here add third sketch as well. This closing point, right click, replace to this vertex. So preview. So this is what we'll get. Means the part with twisted multi-section solid. If we change the closing points of the profiles. Got it. Control Z. I will keep only these two sketches. Sketch it once again onto this XY plane. This time I am going to create one sketch in XY plane bottom over here, which I am going to use as a spine for multi-section. So here it is multi-section solid. Join this sketch to this sketch. Say preview. So here there is something called a spine, and by default it is computed spines. Here it is also showing over here. It is computed spine. What I do is I will give this sketch which I have drawn it. So this case 3 has been taken as the spine and say preview to get the result like this. So according to that spine it has swept and joined these two sketches. So this is a multi-section solid. Okay. So see these tools, see these options. There are more options in that. I will explain it, but just you try this basic one. And this is adds materials, while remove multi-section removes the material. So mentors, please ask students to practice. Then later on we'll see the more in more detail the multi-section solid command. This also students can try and try it with solid combine. Okay. Any doubts, dear students? Are students practicing? Any doubts, dear students? Shall we proceed? Shall we proceed? Okay, we'll proceed then. I delete this multi-section, and here we have seen that we can create these sketches, this first sketch and the second sketch, and in between them material can be added with the help of multi-section solid. Okay, then we have created one profile that can be used as a spine, and it will guide the joining between the first sketch and the second sketch. Similar to the spine, in this multi-section we have guides. Here there are guides. One thing is, spine can be only one. Only one curve we can specify as a spine, while guides can be n number. Depending on the number of vertices, we can create n number of guides. So let us create a few of the guides. In XY plane, I am creating one curve like this. Another sketch in this XY plane. So this is a different sketch. One important thing all of you please notice, these endpoints, it should match with exactly the endpoints of the profile. And there should be coincidence between these ends over here, at this end and the other end as well. Otherwise it will throw error. It will throw the error message. Okay. So here I have drawn another sketch. Exit it. So this is sketch 4 and this is sketch 5. Now the level over here and here it is different, so I cannot use catia to draw the sketch. One thing is, I can draw some 3D spline from surfacing workbench, or as some line also we can use. So this reference elements line point to point, say from this point to this point. So these two lines I have joined. These 2 points I have joined with the line command. Now let us go to multi-section solid. Section 1 is this, section 2 is here it is. Then if I say preview, by default this is what we are going to get. Now I give it guide, and this is the guide. Sketch 4 is taken as guide. So accordingly this vertex will flow along that curve. If I want this vertex to follow this curve, I can click here and then click this particular sketch, that is sketch 5. So second guide curve got added. Say preview. See, this vertex is now following this another sketch, another curve. Okay. Now Now based on this two guides, it is following the other vertices as well. I want this vertex to follow the specific curve. In this case, the line is there. So I will give the third guide as that line. If I have some one more curve to follow this vertex, I can give that as the fourth guide as well. So in this way, this rectangle and other rectangle is joined with the help of the curvature given by the different guides. So for this case, I use three different guides. We can use four guides as well, depending on the number of vertices. Got it? I repeat it once. I say undo I did. So we have two sketches, one rectangle, second rectangle, and these three different guides. So use multi-section between this first sketch and second sketch. Preview, this is what I am going to get. I give guide, this guide. Here I need to select and say this guide. Yes. This one. And the last one. So in this way, we created the multi-section solid between these two sketches with the given guides. Okay. I say undo I did. One thing is that we cannot specify spine as well as the guides. Both of the things we cannot specify, either spine or guides. Both will not, means the multi-section cannot follow both the spine as well as guides. Either spine or either guides. But guides can be a number of guides. Let us modify this particular sketch in this rectangle. Select it and delete. Draw a triangle over here. Let us see what happens. Means one sketch is triangle with 3 vertices, another sketch is rectangle with 4 vertices. Use multi-section between here and here. If I say preview, so it will throw error. Current coupling mode cannot be applied. Change the coupling mode to ratio because the number of vertices are not matching. So here there is one tab called as coupling. Here I will use ratio. But though I will use ratio, so it will itself create some ratio, the perimeters ratio, and then join it. So it is not proper joining, you can say. So let's undo. Let us use another option. Let me doing this. Go to coupling. Here I can add it. Select it and say add. I want to add the coupling from this vertex to this vertex. See, the coupling 1 got added over here. Coupling 1 got added over here. I want to add this to this, and just you click it here and select the 2 points, or you can click on the add as well. Coupling 1, coupling 2, coupling 3. I can use this one to join here. If I don't give coupling 4, it's okay, because it is anyway it is going to join the closing point 1 to closing point 2. So fourth coupling, if I don't give it, so that is also okay. And here we are giving 4 couplings. Say okay. So this is what we got. Triangle joined to rectangle. Okay. So in this way we can use the option called as couplings. I am creating another sketch but in different plane, different orientation. Sketch in this XY plane. So one in XY plane, another in YZ plane. So these are the 2 rectangles here and here. use multi-section from this to this one. Preview. If the closing points are not matching, it may fail. Closing point here to corresponding this, it should be checked. Sometimes the twisting effect may get it like this, as we saw it in simple multi-section as well. But here the computed spine is used. See here, the computed spine is this way. What I do is I cancel, I create my own spine. Let us create one spine. Between, say, this to this, and at last select this as an axis to have symmetry in constant definition. Constant define dialog box. So I have created one sketch 5 as the spine. Use multi-section from here to here. Preview this what we are going to get. Go to spine and select the sketch. This will be sketch 5 will be taken as the spine. So preview to get this as the part. This multi-section solid will add material while remove multi-section will remove material. So for the remove multi-section I create one sketch in this face. So one rectangle we have drawn, sketch, here it is. Exit. Now use the option called as remove multi-section from here to here. Now you will see the closing points are not properly matching. Let us see preview. See it is failing because exactly opposite closing points are there. So here it should be corresponding corner should be this one. So right click, replace and select this vertex. And orientation of this also it is anti-clockwise. So here also it should be anti-clockwise. So click on this arrow. So here the arrow to reverse the direction. Preview. So it has removed material, but you will notice here it is taking the computed spine. Instead of that, what I will do is I will say the spine, which we use it for the multi-section solid creation. Mm, swap visible space and select this sketch. So this is taken as the computed spine. I say once again swap the visible space, preview. So this is what we got. See here. It's all now from here to here there will be direct connection. So this option is nothing but remove multi-section solid. So this removes the material. Just like how we can draw n number of sketches for multi-section solid creation, same way for remove multi-section also we can have n number of sketches can be created. The other options are very similar. Okay, so this was related to most of the sketch based feature tools. These are all our sketch based features. Let us try to create this one. This is a simple part, but you may feel little bit difficulties while creating this stiffener this way. So try to do it. Otherwise, if you are not able to do it, I will show you. Is it okay? So for this, we have to use the stiffener command. Whether students are able to do it, or shall I show how to model this part? Yes, dear students, shall I show you how to model it? Mentors, please reply. So I will show you how to model this part. In fact, this is a very simple part, but still I will show you for those students, those who are not able to do it. So first thing, what I will do is I will create this complete rectangle 120 by 200. This, and for drawing it, as now most of you might be knowing, we need to use one plane, and that should be, for this case, YZ plane we'll use. So select this YZ plane, draw a rectangle. Always we should try to maintain symmetry as we have seen it. Select these two lines using control, and at last the axis, use constant define in dialog box symmetry. This is 120 and our height should be 200. So 200 this way. Okay, exit. To avoid one more feature creation, I can use one rectangle here to create this pocket over here. This is 30 plus 20, 50. 50 on this and 50 on the other side. So 100. So 20 mm this gap is there. So for that we can little bit modify the sketch, so which may reduce our one step. So in this way we can reduce the steps. First thing is I need to make it symmetry. Do the distance as 20 and height. What is the height? Height will be from here to here. It is showing 40 mm. So give it 40. This one to this one. Coincidence. Now remove these lines over here in between. Yes. So little bit modifications we did it to the first picture and then do the pad. For what thickness? 40 millimeters over here. 40. This way. Then this slot with their pocket will draw. So create that first. Draw a rectangle. Give the distance. This side 20, the other side 20. Vertical as 40. This way, and remove the material for 20 millimeters over here with the help of pocket. 20 millimeters as the depth. To get this is the result. Now here this thing we have to draw. Here we will do sketch. Here it is. Draw one circle. R20 inside, R40 outside. 40. Draw inside circle as well. 20. Draw lines as per the requirements, and if the tangency is not created, we have to manually create the tangency. Remove the unwanted portions. Therefore, quick trim. Yes. This distance 40 millimeters for the center. 40. Here distance seems to be 20, so that also we need to consider. See, these lines are not having vertical constraint, so we'll give the constraint for those lines. Vertical, yes. This way. $20. This one and this one we can make it coincidence, or we can do dimension as well. So that is also okay. From here it is 40. So suppose I delete this dimension and give for this dimension and make it 40 mm. Yes. In isometric view, this is what we are going to get. Make exit and make pad for 40 millimeters. 40. Yes. This way. Now we have to create one stiffener over here. So use the ZX plane to create the stiffener. It is very interesting to create the stiffener. If I draw just like this and try to create a stiffener, let us see what happens. It is going to fail. It is failing because this vertically, sorry, along this straight line, it is going to extrude for stiffener, and this is a curvature. So it's not possible to do that way. So what we need to do is, first thing is, for reference I will create over here this option projects allowed to, but that has a construction element, so click this on and this is there. Yes, so make coincide these 2 points, same way coincide these 2 vertices, and little bit extend it here, make off the construction elements, see here, this way. Then we can do the stiffener for 20 millimeters it is. Yes, in this way we created this part in 4 steps, 4 stages. In 4 stages we have created it. Okay, so this is very simple, which we created with the help of stiffener. I am creating one simple part. This way, then make a pad. Here in dresser feature, the most important feature that is called as the edge fillet. Edge fillet, we can select the edges and we can give the fillets. But the most important thing is why we give fillet. We give the fillets to avoid stress concentration at the parts. If there are sharp edges, always there are chances that this will break. Some small impact is there, it will break it because of stress concentration. Another thing is sharp edges can harm the people working with those parts. Also, aesthetics also improves as the fillets are there. Aesthetics also improves because of fillets. For the manufacturing components as well, if the parts are say cast or molded components, easy removal of from the mold or dies. So always it helps to remove the part from the mold. So for that also we use fillets. There are the fillets and these drafts. They are very important functionalities to give. So we'll see what are different options available For the fillet, select this edge, give the value of radius of 20 millimeters and say OK. So it has done the fillet to the selected edge. Very simple. We have given the radius value over here and selected the edges and say OK. I select once again edge fillet, this edge. By default, the propagation option, you will notice it is tangency. So what is the tangency? Let us see. I select this edge and the value of say 5 millimeters. Say preview. So what will happen is this circular edge and this also selected because the tangency option is selected and it will do the fillet here, here and here as well because of option tangency. If I did this and instead of tangency I use the minimal option. Minimal option, okay. Only selected edge will be filleted. Only the selected edge will be filleted. We can select the edges as well as I can select the faces directly. If I select this face and select the value as 5 millimeters or whatever you want, so it will do all its edges the fillet. Okay. So selected edges are now filleted. Fillet this edge 20 mm as the radius. If this is the case, this is what we are going to get. So double click it. By default, conic parameter means it is off and the radius, the fillet is what? Circular one. It is circular one. So there is option called conic parameter. For 0.5 we will not see much difference, but when I change the parameter, conic parameter 0.9 means it will have conical shape. It will not be a circle. Say that conic parameter or the parameter is nothing but the eccentricity. You know the say ellipse, parabola, hyperbola. They are the curves which will have the constant ratio of distance from fixed point called focus to the distance from fixed line called directrix. So based on the parameter value, it may be say ellipse, parabola, or hyperbola. The variation will have. Now see, this is for reduced value of conic parameter 0.1. As it's a ratio, it will have, so it will control the curvature for conic parameter. If it is off, it is circular one default. Okay. So this is what simple fillet, edge fillet. Here we also have something called as variable radius fillet. Select the edge. I can have different radius at different locations. See here, double click it. This one 5 millimeter value. Here 20 millimeters. If I say OK, so the radius is varying from 5 to 20 and it is varying cubically, cubic variation. If I say linear variation, see here, this is what we'll get. I say undo, I repeat it once again. See here, variable radius fillet, this edge. Double click, say 15 millimeter over here, 2 millimeters over here. If I say linear, see, so it is varying from the first value 15 to 2 over here. If a cubic variation, the variation will be cubical this way. Once again I say variable radius fillet, this edge. By default it is taking two edges endpoints. Here there is option called points. I click here and click wherever you want to add one more point. So here I want to have say 20 millimeters as the radius. So this is what we'll get. Linear. This way. This is 20 over here to 20. See, so we can add multiple points as well. If I click it here, say 3 elements, I can click more points as well. So those many values can be given and they can be varied. So this is called as the fillet with variable radius. Here are some other options also, but for time being you practice for these basic options, then the importance of significance of caudal fillet and these other types as well we'll see. Okay, so check these options. If any doubt, please let me know. Mentors, please ask the students if any doubts. Let me note. If required, you can assume the dimensions. Sometimes dimension may be little bit assumed, so you can assume dimensions. This very simple part. Only dimensions little bit we need to modify. Suppose this I draw it in ZX plane R20 and R35. Okay. In isometric view, this will get it. Then mirror extend both side we have to do it. Total is 70. So half of that is 35. Mirror extend. So this is what we'll get it. And here we need to add this portion. So for that we have to sketch it in XY plane. A little bit careful at this because there may be some gap created if we do not take it properly. See, in isometric view, if required, you can orient it for proper understanding how the orientation of the part should be. This will make it symmetric. Make symmetry. So in 6-5 plane we are doing this, and once again we have to give dimension. This is 20. Between these two lines it is 20 only. Now it extends from here to here. It is, they are telling it is 64. So from here to this vertical 64. Now here we should be very careful. This value 20 will be okay. Less than 20 may create problem. More than 20 also it's okay. And height of 20. So exit and make a pad for 20 mm. Yes, there is no problem over here. So it's okay. Now here we have to add this portion. And it's a simple one. Pad we can create in same ZX plane. One square will draw first. Twenty by 20. And it is showing this dimension, means it is symmetric about this horizontal. Yes. So this and this symmetric about horizontal. From the center point to here it is 64. 64 minus 10. So this from this edge it will be 54. So from here to here it will be 54. So that the midpoint will be at 64. Then this I will use for projection. Project 3D element. Yes. Draw one line this way and move to this tangency. This midpoint should be at center. So what we can do is we can create one line as a construction line, as a vertical line, and this can be made symmetric about these lines because already we have positioned it from here. It is 54, and then this one and this one make it coincidence. We'll trim this way. Now this distance we need to assume over here. What is the distance? From here to here it has not been mentioned. So let us give some dimension to this. 10 mm. Here it is, this distance is not specified. From here to extreme end it is 163 they are telling. So this also we can give it 163, and this vertical distance, this also is not given. We need to assume this is 20. So what we can do, this and this we can make it coincidence. Here it is. Remove unwanted portion of this. Yes, exit. Make a pad now. We'll make a pad both side. 15, 15. So total will be 30. See here, in this way, in 3 steps we build this part. Sometimes we may need to assume some of the dimensions. Any doubt? Any doubt? Please let me know. Mentors, you please ask students the doubts so that I will understand whether we are going it fast or slow, what students are gaining or whether they are getting it or not getting. So it will be good for me. So I can accordingly define my pace. So please let me know any doubts, any clarifications. Unless until the students communicate, I will not be able to understand it. All of you please provide your feedback on the provided link. Mentors, please share it to the students.